decided to go on to strings because when we come back after the fall break week, we would be starting on strings. But there were enough people, all semester in the help hours I've been downstairs, there's been nobody there. And all of a sudden now everybody's in there. So obviously we need to review some more arrays. So I decided to go ahead and take a detour and wait on introducing strings until after the break. And we'll go ahead and do some more practice here, more practice problems with arrays. And I've got some, I just wrote out some, oops, there we go, come over here. I just wrote out some exercises just on the fly that we can do. Otherwise, I've got the, this is not the Zybooks, this is my book, and it's got a bunch of exercises in it as well. Some of them you've already done in your labs or whatever, but I thought, well, let's go ahead and start with these, all right? So let's write a function that scales an array by a certain factor. In other words, let's understand what these mean first. What we're going to do is if we've got an array like 1, 2, 3, 4, 5, right? We want to scale this by a factor of 2, right? In other words, I want to go through and multiply each one of them by 2, right? This would lead to 2, 4, 6, 8, 10. Or if I wanted to take the same thing and scale it by a factor of, say, 0.5, then that means I'm dividing by 2. I'm multiplying by 1/2. And that would mean that I've got 0.5, 1, 1.5, 2, and 2.5. Right? So in other words, we're going to be operating on arrays of doubles now instead of integers. Okay? So that's what I want to do for our first exercise here. What I've done is I've set up an arrays.h and arrays.c, and I've also got a demo here where I've got an array that I can start testing things. On your hack, we've given a lot of this apparatus to you, right? We gave you an ad hoc tester that you can use for sanity checks and for firing up GDB or Valgrind or something like that. But also, for the 2D version, we gave you an entire program that manipulates an entire image based on your functions. If you want to flip an image or flip it horizontally or vertically or rotate it. Right? So I've got my array here, which has 8 elements. All right? Let's go ahead and write this function, again, that scales it by a certain factor. Okay? Well, I didn't specify what the return type on this is going to be. So let's go ahead and initially make it a void function. Right? And I'm going to just say scale. Right? There we go. I'll call it scale. It's going to take an array and anything else that's necessary, including the factor, and it's going to scale everything inside that array. So how do we model that array? Is it just, well, first of all, is it just one integer? Is that an array? No. We model arrays using pointers. Right? Now, as I said with our example, it's not going to necessarily be integers, especially if we're multiplying by 1/2. I want to preserve those fractional values. So now it's going to be doubles. And in fact, we've done a couple of examples like this already where we put const in front of it, where we're making the promise that we're not going to change the contents of your array. But now it's different. Are we changing the array? Yes. So if I have const there, then I won't be able to actually write this function. What else do I need? Anytime you pass an array to a function, what does that function need to be told? The size. You can call it size. You can call it n, whichever one. Right? What else do I need? That certain factor. If I multiply by 2, or if I multiply by 1/2, or if I multiply by something. Right? So here's our factor. And I'll make it a double here, too, because factor. Because it could be 1/2. Okay? I initially made this a void function because we're not returning anything. But could we return something? What? An error code. Right? And then we can do some basic error handling here. Okay? Before I move on, what should I do? I should write documentation. This is still something we're seeing a lot of folks miss. Every prototype needs documentation like this. And this is doc style comments. Right? We don't ding you for not having doc style, but we definitely ding you for not having all the documentation. Right? Scales, that is multiplies each element in the given array. Right? the given, here, I could say in the given array by the given factor. In fact, in your, if it helps you to understand what a problem is or what a function is doing, you can also give the example. I've erased the example since then, but I could say that, for example, if the input array is, and then give it an example, 1, 2, 3, 4, 5, and the factor is 2, let's say 0.5, then the array is changed to 0.5, 1, 1.5, 2, 2.5. Right? There. That's perfectly fine documentation. Right? It's a little bit verbose for me because I understand what we're trying to do here, but if you need to, if it helps you to understand the problem by putting in an example, great. Go ahead and do it. Right? Now let's actually write this function. I started out with the simplest function here. Right? I go over to the source file. I repeat the signature here. What is the first thing that I do in any function and every function? What was the last module that we, before debugging, that we looked at? Check for errors. Error handling always comes first. So what could go wrong with my inputs? What could go wrong with the array? It could be null. If the array is null, then can't do anything. Return null? Does my return type look like a pointer to you? Nope. So return an error code. 0? 0 means no error. This is some kind of error. In fact, I should go back and change this so that I'm not using magic numbers, right? Null pointer error, and then define either an enumerated type or a bunch of macros to do it for me. Define macros. For now, though, for this exercise, I'll just go ahead and leave it as 1. What else could go wrong? What about n? If the array is null, or I don't know, n is 0. That's actually a good point. Could it be 0? Well, the loop that I'm about to write, it'll end up doing nothing then. So who cares, right? If it's negative, that's bad, right? But you can have, I mean, it's not that usual, but you could have an array of size 0. Right? Go ahead and scale this empty array. Right? I don't know. It depends. At that point, that's called requirements elicitation. You go back to whoever told you to write this function and you ask for clarification. What happens if n is 0? What should happen if n is 0? Right? I agree. Let's go ahead and call it an error. Right? Whatever the greater is what you should do, though. Right? Is there any problem with factor, though? Remember, we're not dividing by anything. We're multiplying it. So 0 is fine. 1 is fine. 0.5 is fine. -1 is fine. Right? I don't see any problems with factor there. Right? We've taken care of that. Also, don't forget to return a 0 error code at the end for no error. Right? All right, now it's pretty straightforward. It's an idiomatic for loop. For int I equals 0, I is less than n I plus plus. Right? How am I going to scale each element array sub I? Right? Array sub I is equal to array sub I times the factor. Right? Is there a more compact way of writing that, though? Times equals. There we go. I like that even more. Perfect. Now we need to determine, were we correct? If you are compiling manually, that's perfectly fine. Remember, it's gcc-c array utils.c. That produces, if I'm using null, what do I need to bring in? The standard library. Right, there we go. That's what it's complaining about here. And that's the only thing it's complaining about. Good. There we go. So that will produce, over here, I will refresh, that produces a .o file. Right? Anytime that you make a change over here, you have to recompile. Right? That's one of the problems that we've been seeing in lab and help sessions, where You make a change and you think, okay, well, now it works. And then you don't end up recompiling, and oh, it doesn't work, even though it was correct, right? And then you start racking your brain back and forth. Something's going wrong here, right? Always remember to recompile. I will then gcc array utils, array utils.o, array, I called it demo, sorry, demo.c, and that produces an a.out file, which is not doing anything at the moment. Again, it's only two things that you have to do, but anything more complex, we give you a make file to do that. For example, for your hack, if you just make, right, or make all, it'll build everything automatically for you. You don't have to do compile this, compile that, right? Just use the make file that we gave you. And then, if you want to, dive down that rabbit hole and understand how to make your own make files. All right, it's not doing anything because, obviously, I'm not calling that function because it didn't exist yet. So let's do that. Actually, this is not a double array, so let's go ahead and change this into a double array, right, for a second, right? I don't know, let's add some variety here, 0.5 and 0.2. Right? The rest of them can be whole numbers, it doesn't matter. Scale the array of size n for me. Right? And then I want to make sure that it works. So we could print it out here beforehand, print it out afterwards. Uh-oh. I don't see any print functions here. Do you? So let's go ahead and start writing our own. No, that's why I've got this up here. Right? Hey, we did that in lab. Why don't we just steal the code from that? It is not stealing, right? If you've written code somewhere else, you can. This is what we mean by helper functions. At the end of the hack, we say you are encouraged, in fact, you should include any helper functions that you feel are necessary. So for example, I'm going to steal the print array function from somewhere else. And here's the implementation, print array. There we go. I'm going to have to change this to doubles though. Right? And move this over here, or copy this over here. It is perfectly fine to reuse any code that you've made, reuse any code that we've given, either in lab, as starter code for your hack, or from the lecture notes that are posted to GitHub. Right? Use it. Right? I will go ahead and change this to a double though, because that's what we're working with here today. And this is going to be %f and %f. Right? I think that's good. I don't want to print them out too long, so let's just go with 2 decimal points of accuracy there. All right. Now, if I just, recompile the main here, it's not going to work because I don't have the this print function in that .o file. I'm going to have to first compile everything together there. And now that I'm using standard input-output, I also need to put in stdio there. Okay. Now let's print it out. Print array, ARN, and then print it after, before and after. This is ad hoc testing. Here's your array beforehand. Here's your function call. Print it out to make sure that it worked the second time. And gcc array.out. Oh, oops. Double const int. Oh, I didn't change it over here, did I? There we go. Double. There. Compile that. Compile that. Uh-oh. Too few arguments. Oh, I didn't give it a scale. Darn it. What should my scale be? 0.5, because that's the example that I wrote. All right. A.out. Does it look like it worked to you? Is it scaled? Is it everything in the second one is half as much as the first? Yep. Great. That one's done. That was the simplest one. Write another version of that function that returns a new scaled array. In other words, I want to do the exact same thing, but a copy. Gee, that sounds familiar. That's what you're doing right now, right? But now I'm not going to mess with the actual array that you give me, so I can put const in front of it. Good? All right. Everything else is still the same. So my first instinct here is to copy, paste this into my function here. Does that sound like a good idea? DRY, don't repeat yourself. If I have a function that scales something for me, use it. Right? can I do this? Scale what you gave me by that factor. Let's find out. Will that compile? No. Because scale copy says, I'm making a promise here. I'm not making any changes to this array, but I am passing it off to a function that does make changes to that array. The compiler is able to find that, to figure that out and say, no, you can't do that. That is a read-only argument. Discards const qualifier, right, from pointer cast. So no, you can't do that. Besides, I wouldn't want to do that. I don't want to change the data that you gave me. I want to change a copy of the data that you gave me. Right, that sounds familiar as well. I'd really love it if we had some sort of a deep copy function. Well, guess what? You do, right? Where is it? No, it's not in here. Instead, let's take this opportunity to remind everybody where the lecture notes are, right? So here is the GitHub page. There are the notes. In fact, notes going back 5 years, but you probably want to focus on this year. Right? And there's this course, there's arrays, and where's that deep copy array function? Grab it, including the documentation. You don't even have to write it for it, because we wrote it for you, right? All right, bring it over here to this, and I will grab this. I just want the header over here, and I want the actual implementation over here. Order really doesn't matter. Oops, darn it. I didn't copy that part. There we go. There. Deep copy array. Right? Except that it's for integers. Right? So if I wanted a deep copy for integers and a deep copy for doubles, I would have to say deep copy int array. And then cut and paste that and make that into a double array. Cut and paste that and rename it into a copy double array, right? Because you don't have function overloading. One function name and that's it. They all have to be distinct. I will go ahead and change this one to a double. What else needs to change to a double? The copy, the cast, and the size of. Does anything else need to change? For each element, just simply copy whatever is in the original array over into copy. Right? We're good. You should change this over here, though. Right? There we go. Now let's go back to my implementation of, where is it? Scale copy. Gee, I wish I had a deep copy. What was it called? Deep array, copy array. Right? There we go. Array and capture that value. Double copy is equal to deep copy array. Scale, not the original array, but the copy, and then return. Return what? Do I return the original array? Nope. I return nothing. Can't do that either. I return copy. Oh, ooh, you're right. Can I return the copy? Nope. So what should my return type be here? Okay, double, but just one of them? I'm returning an entire array. Double star. Now let's come back over here to the H file and change that as well. There. But that raises a point here. How do we do error handling when it returns a pointer? Right? Some bad things could happen. If the array is null, then you certainly cannot copy it, or you shouldn't be copying it. If the n is less than 0, then that's an error too. Can I return 1? Think about the implication of that. That there's an error of type 1, right? Is that a point? But our return type is a pointer. What does returning 1 tell the calling function? I created your array, and it's at memory location 1. Does that sound like a memory location that belongs to you? Probably not. What is the only thing that I can return as an error message to the calling function when something goes wrong when my return value is a pointer? Null. That sounds familiar. That's exactly what malloc does. Right? When you ask malloc for 50 million terabytes of RAM, right? You're not gonna get that much, right? So what happens? It returns null, saying I was not able to allocate any memory for you. Right? That's what we're doing here. That's the only thing that you can do. You cannot return dead beef. Right? There's no, I mean, you could define it and return and do something like that, but the only thing that is defined by the standard library is null. Okay. Let's come over here and test that now. So instead of calling that scaled function, which I know works, right? I will go ahead and say double BUR. Why BUR? ARR is short for array. What comes next? B, BUR. All right, scaled array n and 0.5. Right. See, oops. Compile it all together, or learn how to make files so that I don't have to do this. Oops, it's not copy. All right, clear this out. Let's try this again. Implicit did I not copy that? Come on, what? Deep copy array. There it is. And where's the deep copy array? Double. Oh, double. There we go. That was the problem. So you change the header file or the source file, you need to change the other one. Come on. Gee. Still a problem. Deep copy array. Deep copy array. Deep copy array. Deep copy array. ... Deep copy array. Oh, still an integer. Double. Sorry. There we go. I should have started clean. Now you see what happens when you copy pasta. All right. Still bad. All right. I must have not have changed it somewhere. Const double array. Deep copy array. Deep copy array. Oh, you know what the problem is? What am I not including? Yeah, I'm not including my own header file. The problem here is that the compiler is not seeing it because I use it. Where do I use it? I use it right here, but where is it declared? After. Order matters if you're using function before you define a function, except that if you include the header file, it knows about it. Array utils.h. By the way, do you ever do that? Let's find out what happens when we try to do that. The compiler is stuck in an infinite loop. Why? What is it doing? Yep, it's doing a cut and paste. It is taking this file and saying, okay, cut and paste it. Guess what's still at the top? That same thing. So cut and paste it. Undo, undo, undo. I don't want that. Right? So it got caught in an infinite loop because I included the source file, which you never do. Right? GCC. Great, now it works. GCC, there we go. Right? Oh, and then I'm using, I'm not using any math here. Oh, it should be scaled copy now, right? Scaled copy. There we go. Huh, still a problem. Didn't I call it scaled copy? Or scale copy. Okay, scaled. There we go. Make sure that you spell everything correctly. Or if you spell it incorrectly, at least make sure that you're consistent on your misspellings. Right, there we go. All right. Oh, duh. I'm printing out the exact same array. What should I be printing out? Burr. There we go. Go ahead and yell at me whenever I make a mistake. If you see the mistakes, please go ahead and yell them out. This is a collaborative thing here. All right. All right. Does that look good? All right. Good. Let's keep going. There's my other version. Write a function that takes two arrays and swaps their contents. Right? So this function swaps the entire contents of the two given arrays, which are assumed to be of the same size. Because if I gave you an array of 5 elements and an array of 2 elements, can you swap their contents? What happens to these 3 guys right here? It doesn't make any sense. Oh, you could pad them out like you're doing right now, right? Like swap these two, this pair right here, and then leave these three guys alone, maybe. Right? You could write that function, right? I'm going to go ahead and assume that they're of the same size, though. Right? So what should I call this? Swap arrays? That's good enough. Right? What's the return value going to be? If I'm going to be doing any error handling, it should be int or an error code of some sort. I'm going to take two arrays. So we'll do doubles again. Double A and double B. Right? Or BR. I don't know if anybody else that does that. So don't ever quote me on that. Right? Int n. Right? Say same size, and then we'll put that in the documentation that they're n. Okay? Swap arrays. Kind of like what you're doing right now, a little bit. Right? Except that instead of swapping two different arrays, you're taking one array and you're swapping individual elements. Right? What if I put a const in front of this? Is that going to work? Not if you're going to change the contents of it. Right. All right, then let's write it. Go cleanly down at the bottom here. Right. Okay. What's the first thing that I do? Error checking. That should always be the answer. What is the first thing you do in every function, period? At least do some error checking or think about error checking. If there's no errors to check, then fine. Go about your business. But if the array is null, if you're ever going to do any error checking, the first thing you do with error checking is the first of the first is going to be null pointer checks. So if the array is null, or BR is null, or, and then you can decide what bad ends there are. N is less than 0. Right. Return 1. Oh, thank you. Bad typing. Otherwise, return 0. All right. Now here's where you write your actual function. So, basic idiomatic for loop. For int I is equal to 0, I is less than or equal to n. That's another mistake that we're seeing all over the place. Right? This is why you go with idiomatic for loops. Right? We saw this mostly on lab, I forget whatever, lab 7, because a lot of people were just taking the code from labs 4, where you did the multiplication table, but you printed it out. There it made sense to start at 1 because that's where the multiplication table started. Here it doesn't make sense anymore to do that because it is an array. Start at 0. Don't correct the indices, correct the values. Right? Don't go up to n. That's a segmentation fault waiting to happen. All right, so for each one, all right, how do I swap two things? If they were integers, I would have a temporary integer that takes on the value a. A is now free to change its value to b, and now b is now free to put the temporary value back into it. But I don't have just regular old variables here. What do I have? Arrays. So let's take the ith element and put it into a temporary value. That frees up the ith element to take on the value in the birth ith element, right? And then birth of ith is equal to temp. Right. Good? All right. Yay. Let's come over here and let's see if it works. Now I've been erasing and adding and erasing and adding back in, right? Don't do that, right? We give you a tester, right? Don't just erase anything. Just add on to it because you want to make sure that you don't break anything. You go back and you fix something and now you need to rewrite all that code. That's why you don't really do ad hoc testing like this. You want to make sure that you're adopting some sort of a unit testing framework early in your career. We're not expecting anybody to write from scratch any CMACA stuff at all, right? But we did want to expose you to a formal unit testing framework so that you know what one looks like. Right? We don't expect anybody to write any CMACA stuff because CMACA is the way that we rewrote CMACA is that we have to give it function pointers, which we have not covered. We will by the end of the course, though. Okay. All right, so let's get rid of that. Let's print them out, and then both of them out. Oh, I don't have BR, so maybe I want that. There we go. I'll put that up there. Print out R and BR printed out again after we've swapped them. What do I call it? Swap arrays. Right. And BR, and N. There we go. GCC everything. And again, here's where a make file comes in handy. If I created the make file, I would just type make. A.out. They look swapped to you. Remember, the first two are A and B. The second two are A and B, but they seem to be swapped to me. Right. Oh, get rid of that. Oh, first one's off? Oh, no. Good observation. What happened there? R, BR, scaled copy, BR gets it. So we ended up changing. Ooh, wow. What happened? I'm glad this happened, actually. Oh, thank you. You just gave us spoilers, though. Darn it. I was hoping I would make a mistake like this. Sorry, silence. Don't listen to him. Right? So, gee, I wonder what happened. I know that something happened around, as you said, line 60. So let's take this as an opportunity to use that tool set that we've now been introduced into. Make sure that you are compiling with the G flag and compiling with the G flag over here. There we go. And we can fire up GDB, A.out. Right. Now, I want to set a breakpoint in the file arrayutils.c at line 60. So I can say break arrayutils.c line 60. And it'll set a breakpoint there. Right. Because if I set a breakpoint at line 60, is there a line 60 in the demo file? No. I have to, if I am now using multiple files, I have to specify which file are you talking about. Right. Probably, yeah. Break 60. Yep, no line in the current file. On future shared library or load? No, don't do that. Right. Layout source so that we can actually see it. Let's run it. Refresh it because sometimes it donks itself up. And now we're at line 60 here. Take a look around. Backtrace full if you want. Backtrace 2 words full. There we go. And I'm in swap arrays. Temp is equal to 7. I is equal to 0. N is equal to 8. More. There's the array. 1.5, negative 5, 3, 9, 4, etc., etc., etc. Hey, that 10.2, it ended up not being 10.2. Why? Because that's how numbers work, right? 1/3 is not 0.3 infinite threes because you don't have an infinity. You have 0.3333334 4, and then 4 at some point. 0.2 is not even representable exactly. It is 10.1999999, right? And then at some point those 9s end. Right? So be careful. This is why you build in a tolerance, right? A lot of the testing stuff in Hack 5 was looking at exact stuff, and then they were doing weird stuff in the background, like trying to round it so that it would work out. But that's not the way that you do it. The way that you do it is you build in a tolerance. That's close enough to 10.2 right there. Okay. All right. So print temp. Okay. Is that okay? Next, print temp. All right. So we received the first value 1, except that the first value was not 1. What was the first value? 1.5. So right now we see that there's a problem, and the problem that you identified already was, that's not an integer, that is a double. Good. Recompile everything once again. There we go. There. Now it works. All right. I was hoping for an error like that so I could remind you that GDB is the thing to use. Right. What next? Got time. Write a function that merges 2 arrays into one larger array. Right. So this function merges two arrays into one new array. Right? So for example, if the two arrays are 1, 2, 3, 4, and second array is, I don't know, 7, 5, 4. It's best not to just always go contiguous, because then you get the sense that, oh, does it always have to be sorted? No, it doesn't always have to be sorted, right? And it doesn't always have to be contiguous either. Then it would return a new array containing 1, 2, 3, 4, 7, 5, 4. There we go. There we go. That's what I want. Let's call it merge, or merge arrays, whatever. That means I need to take two arrays, double, ARR. I'm not going to be making changes to it, so I'll immediately make it into a const. And I need to tell the size. Are they always going to have the same size? No, that's why I chose this example. One is 4 and one is 3. So I need to say that the size of array, int size of array, or n. And then I need another array, const double ber, and int size of ber. There. Okay. What's my return type going to be here? If I need to return a new array, it's not one double, it is many doubles. Now, in one of the examples that you did in your lab, that we basically did in class, that filter threshold thing, right? Where you're given a bunch of numbers and you want to return anything that is greater than 2, greater than or equal to 2. Then that means that you would return something that looks like this, 2, 3, and 4. When we designed that function, we also had to give it a pass by reference value, the size of the new array, so that we told you, oh, by the way, the array that we gave you has 3 elements in it, right? Is that necessary here? If I'm giving you these two arrays and their size, do I need to be told what the new size is? 7. Right? I can do that math. Right? I needed to be told what the new size is because with the example from class and the example from lab, because otherwise I'd have to do all the work manually. I'd have to go through and count up the number of things, and if I'm going to have to go through and then count up the number of things that are in that new array, I might as well just make the array myself. Right? So this, I do not have to have a int int size of result. I don't have to have that because you can add two numbers together, right? Especially if you have those two numbers. All right. Merge. All right. First thing you do in any function is error checking. If it gets redundant, but yeah, that's what you got to do. Or ber is null, or size of r is less than 0, or size of ber is less than 0. Then simply return 0. Nope. What's my return type here? It's a pointer. What's the only pointer that indicates an error? Null. Thank you, Bret Hart. Right? All right. So what do I need to do now? What's the second thing I need to do? If I'm going to create a brand new array and return it, what function am I going to have to call? Say what? Here, could I do this? Double result, and I'll just make it of size of err plus size of ber. What kind of an array is that? It's a static array, allocated on the stack. If I did this with 10 million integers, or 10 million doubles, or even 5 million doubles, show's over. You have filled up your stack, you've filled up all the memory, and you have what happens when you fill something up and you keep going, overflowed it, that's stack overflow right there. We do not like static arrays. We like dynamic arrays. How do I allocate for memory for a dynamic array? Malloc. Memory allocation. When I do it for a double, I typecast the return type as a double, star. How big should it be? Size of double, because that's doubles, times size of the original array plus size of BR. If the originals were 4 and 3, then the result should be 7. Is that good math right there? Nope. Bad math. Parentheses. Good. Good math. Right. And now I can return that result. Except that, is that stuff in the result yet? Nope. What do I need to do? I need to copy everything in ARR over. Then I need to copy everything in BR over. For int I, the first part is the easy part. For int I equals 0, I is less than size of R, I plus plus. This is why I like using N and M, because I don't have to type so much. Right? But for illustrative purposes, for demo purposes, I'll go ahead and write it all out. The result sub I is equal to array sub I. There we go. Now do it for B. For int I equals 0, I is less than size of BR plus I plus plus. Result sub I is equal to BR sub I. Is that going to work? I'm just overwriting everything that I just wrote. I wrote those first 4 things, and then I'm going to write those second 3 things, right? And I never, what I wanted to, I want to write these first 4 things, and then these next 3 things. Okay, so what do you mean by that? Where should I start my new variable? I equals size of R, or size of R minus 1? Good question. Well, there are 4 things in the original array, right? This is why having a whiteboard, having a piece of paper, writing it out, 0, 1, 2, 3, right? And in fact, when you do your image rotation, do exactly that. In fact, in the repo that we give you this 6-pixel dummy image. Right? It's only 6 pixels. It's like 2 by 3 pixels so that you can actually visualize it and look how it moves over. Name these pixels, 1, 2, 3, 4, 5, 6, and then rotate it over so that you see it's 4, 5, 6, 1, 2, 3, right? And then look at the mapping and how that works. Write it out on a piece of paper to figure out the math. For this one, write it out in my head here. I copied the first 4 things, 0, 1, 2, 3. So where should the next one be? 4, which is the size of R. Right? So not minus 1. What about this guy right here? That's not correct, okay? What should I go up to but not including? Well, the size of this thing right here. Right? So put that there. And now I've got a really strong argument for maybe putting this into a variable, so I don't have to worry about that crap. Int size of result. Yay. Now I can take that and put that over here. No parentheses needed. Good math. No parentheses needed. Good math. So, GCC, no syntax errors. Obviously I'm not calling it, so let's do it. So we've swapped those arrays. Let's go ahead and get rid of that. Print those out. Double cur is next. Is equal to merge of n, BR, n, and then print the array. And again, I don't need to be told how big that result is. Why? I know how big it should be. N plus n. Right. So the first 8 things looks like it's good. Uh-oh. The next 8 things don't look so good. All right. So let's come back over here and figure it out. In fact, instead of scratching our head, let's use some of our tools. Valgrind, Valgrind a dot out. Valgrind a dot out. There we go. Dot slash a dot out. All right, so don't worry about the memory leak. That's just in the main. But there's definitely a, come on, where is it? Way up here, maybe. There we go. Invalid read of size 8, where? On line 78. At least that tells us what line we should be looking at for errors. So tell me about that line. Again, a piece of paper, a whiteboard, those are going to be your friends. Right? Failing that, if you want to, you can copy everything over here into Python Tutor, and you can actually see it as you walk through your program. Right? So tell me about, I over here is fine because we fixed all this stuff. But what about this I right here? Size of R is 4. We start at 4. Is there a fourth element or a fifth element over in Burr that goes from 0, 1, and 2? Nope. So what have I done? I've gone past the array that I allocated, and I'm copying a bunch of garbage now. That garbage happened to actually be just a bunch of zeros. What should it be right there? Correct for it. The first one should be 0. The second one should be 1, 2, 3, etc., etc. I was what we had before, but that starts here. On the first iteration, how do I make that? Again, if you have a piece of paper, you would write this stuff out. If I start at array of size of array, and that's 4, but I want that to become 0, and then I want this to become, I want it to go from 0 to 1 to something, right? Something, 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 something. And I want that to become 0. I want that to become 1. I want that to become 2. Right? So what do I do? Well, here, let's write out the whole table then. Right? For size of R, that's going to end up being 4, right? And so I will then start out at 4, 5, 6, 7. Actually, it will stop right there because size of result is what? 7 for our example. Right? So I will run from 4 to 5 to 6. But we want the index to become 0, 1, and 2. Do you see a common pattern there? What's the difference? The size of R, 4, and to be exact in this particular case. So I minus, size of R. Right? You can go ahead and comment that out, right? Don't leave it in your final submission. All right. GCC, good. GCC, good. There. First 8 look good. Did the second 8 look good? It looked good to me. We only have 2 minutes, so there's no way that I could do it. Ooh, with only unique elements in it. Oh, come on. Now it's frozen up, so sorry. Can't do it anyway. There we go. Now it's back. All right. Write a function that returns a new copy of an array with only unique elements. So in other words, if we had the array, say 5, 8, 3, 9, 4, 5, 3, 2, 2, 2, 2, there we go. We would want to return a new array that contains 5, 8, 3, 9, 4. That 5, that's not unique. We already have that in there. 3, we already have that in there. We don't have 2 in there, so we'll add that, but then we'll ignore the other 3 copies of it. Right? That was going to be the most complex one. We can do it on Wednesday along with our review because we're not going to be able to take the entire time for the review. But remember, debug reading is due on Wednesday. Hack 7 is due on Wednesday. When we have lecture on Wednesday, it'll be simply a review because your Friday is your exam time. Right? There is a hack on Thursday. It's your debugging hack. We give you a tic-tac-toe program with 5 or 6 bugs. You have to hunt them down and fix them. Right? And then play tic-tac-toe. And you get used to winning. And you do have to test it, so you'll be playing tic-tac-toe with a computer. Or with a friend or yourself or whatever. Right. Any questions? All right, then have a good break.